This video is going to look at general strategies for solving identities, and it would be helpful for you if you had that piece of paper that I handed out in class, General Strategies for Proving Identities, and we'll look at some of the different helpful strategies. So like for this problem, when I look at it, I see all those squareds and I think, oh, that's probably one of the Pythagorean identities. So I would go down off to the side and write sine squared x plus cosine squared x equals 1. That's my main Pythagorean identity. And this has a tangent in it, so I'm gonna divide everything by cosine. And there's an identity that says tangent squared x plus 1 equals secant squared x. So when I look at that, I'm not sure if that'll help me because it would only help me if that was 1. But that looks like a Pythagorean identity too. So I'm going to take the Pythagorean identity, think off to the sine side squared x plus cosine squared x equals 1. If I divide that by sine squared x, I get 1 plus cotangent squared x equals cosecant squared x. And then when I compare this one to this one, I can think to myself, well, if I just moved the cotangent over, then this identity would become 1 equals cosecant squared minus cotangent squared. And that's what I want. So this piece right here, by the Pythagorean identity, is 1. So this is tangent squared alpha plus 1 equals secant squared alpha. And now my other Pythagorean identity says that tangent squared plus 1 is secant. So I can say secant squared alpha equals secant squared alpha. Check, check. These are both the same. So it's an identity. Identity is when two sides are the same. Now, all this stuff at the bottom you don't need. Oops, didn't mean to do that. The stuff at the bottom, these are the rules that you're thinking about in your head, but the work at the top, that's the identity. And if you talk about special strategies that I used, I did this entire identity with strategy number 2, look for expressions to which the Pythagorean identities can be applied. So remember, you can't cross multiply when you do these. Cross multiplying would actually be nice because I get 1 minus cosine squared equals sine squared, and that's true. But in order to be an identity, you have to simplify one side until it's equal to the other side. And that can be a little bit trickier, but I'm going to start off with looking over here. This has a 1 plus cosine x on the bottom. I want to have a 1 plus cosine x on the bottom over here. So I'm going to use the special strategy, which is number 5, multiply one side of the equation by an expression equal to 1. So I'm going to take 1 minus cosine x over sine x, and I'm going to multiply it by 1 plus cosine x over 1 plus cosine x. This aids me because I'm making the bottom on the left side look more like the bottom of the right. And so now, on the top I'm going to FOIL, which is actually special strategy number 3, look for opportunities to use algebra, including factoring and foiling. So on the top, I FOIL, I get 1 times 1 is 1, and the outside and the inside cancel, plus cosine minus cosine. So it's 1 minus cosine squared x over sine x times 1 plus cosine x. So now I'm back to another strategy that helps, strategy number 2, look for expressions to which Pythagorean identities can be applied. Because I know over here that sine squared plus cosine squared equals 1. And so that means that sine squared is 1 minus cosine squared. So I can take this 1 minus cosine squared and replace it with sine squared x over sine x times 1 plus cosine x. And now one of my sine x's cancels, so one of them cancels, and I end up with, then I'm sort of out of room, but I end up with sine x over 1 plus cosine x. So now these two pieces are the same, and so I just proved it was an identity. Check, check, they're the same. And in that example, I simplified one side, and I had to use two different strategies. My first strategy that I used was strategy number 5, multiply one side of the equation by an expression equal to 1, and I did that so I could get the bottoms the same. And then I also used strategy number 2, look for opportunities to use the Pythagorean identity. So in this problem, I'm going to look at the general strategy number 2, transform both sides of the identity into the famous expression, because on the left and the right, they both look a little complicated. So I'm going to write this as cosine x times cosine x over sine x, just so I know where I'm headed. If I can get a problem down to 2 cosines on top, 1 sine on the bottom, then I've got it. So this is just sort of screaming at you, FOIL. That's strategy number 3, look for opportunities to use algebra. So it's going to be cosecant x times sine x first. Outside is plus cosecant x. Inside is minus sine x. And then minus 1. That sort of looks terrible. I hope it simplifies. So let's look at this piece first. Cosecant is 1 over sine, and then that's sine. So this piece right here simplifies to 1. So I have 1 plus cosecant x minus sine x minus 1, and that allows this one to cancel this one. So now I have cosecant x minus sine x. Okay, but over here on the right, I'm trying to get this equal to cosine squared over sine. And so I'm looking at the left. The left is subtracted. The right is a single fraction. So if you can think of the left-hand side as 2 fractions, 1 over sine x minus sine x. And I think of the right-hand side as a single fraction, then I can use strategy number 4, look for opportunities to use number operations, such as getting a common denominator. So I'm going to multiply this as sine x over sine x. So I end up with 1 minus sine squared x over sine x, which leads me right into strategy number 2, look for expressions to which Pythagorean identities can be applied. The top part right here, 1 minus sine squared, is cosine squared. And so if I look at this expression, and really like the piece that's right here should be going underneath, but I sort of ran out of room again because they get kind of long. And so I would say on this problem, I simplified the right-hand side of the equation and the left-hand side of the equation to the same form. So I did general strategy number 2, transform both sides of the identity into the same expression. These are the same, and so it's an identity. So on this one, I'm looking at secant x minus cosine x over tangent squared x, and I'm going to try to prove that this is equal to cosine of x. And in this case, since the right side is a lot simpler than the left side, I'll probably just work on one side until I can get it all the way down. And so one of the general strategies is to write everything in terms of sine and cosine. So I'm going to write secant as 1 over cosine minus cosine, which is cosine over 1, and that's over tangent squared. Now my Pythagorean identity says that tangent squared is secant squared minus 1. Yeah, I had to look that one up. And I don't think replacing this with secant squared minus 1 is going to look any nicer. So instead, I'm going to work on the top, and I'm going to use the general strategy, the special strategy that says to look for opportunities to simplify fractions. So in this case, I'm going to try to get a common denominator for this part right here. So I'm going to multiply this by cosine of x over cosine of x. So now when I add fractions, I add the top, keep the bottom the same. And as long as I'm at getting it into sine and cosine, I think I'm going to turn the tangent right here. I'm going to turn that tangent into sine squared x over cosine squared x and see if that helps at all. On the top, I've got 1 minus cosine squared x over cosine of x. Let's see. So now I'm trying to look at what looks familiar, and this top piece right here looks like one of my Pythagorean identities, and it's sine squared x. So I've got sine squared x over cosine of x over sine squared x over cosine squared x. And so if I take this whole piece right here and I flip and multiply, I'll end up with, let's see, sine squared over cosine times cosine squared over sine squared. Sine squareds cancel. Cosine squared over cosine is just cosine. And I've managed to simplify the whole side until both sides are equal, and so check, it's an identity. And if I look at the strategies I used on the top here, well, first step was to get everything written in terms of sine and cosine. Second step was to get a common denominator for the fraction. Third step was to recognize the Pythagorean identity, and then I had to use algebra and flip and multiply. One general piece of advice: if it starts to look worse and then it looks better, that's okay. But if you start to make something looks worse and then it looks more worse, I don't think that's a word, and then it just gets terrible, and all of a sudden you're at 3/4 of a page and going nowhere, just stop. Start over, try a different strategy. I'll see you tomorrow, and we'll be working on identities.